Hello students, in this session we will see the second part of units and measurements, right? In the first part we saw like what is meant by fundamental units, from which how should we do the derived units, okay? That is something that we saw in the first part. Same way we did see those exceptions cases, okay? So exception is like angle and then the solid angle. We did see both of them. Then we had an intuition of what is meant by area and then volume, okay? You should know that one. That is something that we have seen in the last session. Same way, we saw what is meant by parallax method, okay? From the understanding that we got from the degree, we were able to do what is meant by parallax method. Then we did see errors, okay? So how does an error come in a value that we are about to measure, okay? When you do a physics experiment, you always have an error in that value. So how to overcome those errors? That is something that we have seen in the last session, fine? So those are the things that we have completed in the last session. So in this session, what we are about to see is like propagation of errors, okay? So how does an error propagate? As you add two values or as you multiply two values, that is something that we are about to see now, okay? So in all those things, right? In addition and then subtraction, we will see how does an error propagate. Same way we will see like in multiplication and then division, how does an error propagate, okay? So we will see both those things, fine? So in addition and subtraction, they propagate in same fashion. Same way in multiplication and division, they propagate in same fashion. We will do that one. So from multiplication, we will be able to do the powers, okay? So if it is going to be a square, how does an error propagate, okay? So both are the same understanding. Multiplication, division and powers will have the same understanding, fine? So we'll do that one. Then we will see like significant figures, okay? When you do an experiment, you get a value. So what all are the values that is significant, okay? When you do unit conversions, we'll be multiplying it with zeros, okay? So what all are the units that you should, numbers that you should consider, okay? That is significant figures, fine? So you should know that one. Then what we will see is like dimension analysis. That is going to be the last part of this chapter, right? So in dimension analysis, we have two units, right? Left hand side and the right hand side in an equation. So the units of the left hand side should match with the units of the right hand side, right? From that understanding, we will be able to derive a simple formula, right? So that is going to be the formula of time period of the pendulum. We will be able to derive that one, okay? So that will be the example that I'll give. So with that, units and measurement chapter will get completed. Same way, there is going to be an extra part which will be the next session. In that session, we will do screw gauge and then the vernier caliper, okay? So with all those things, first chapter units and measurements will get completed, right? The first thing that we will see is like propagation of errors. What is meant by propagation of error? So when you do a mathematical thing, you will have an error that is going to get propagated. So in what fashion it is about to propagate, that is something that we are about to see. The first one is addition and subtraction. For addition and subtraction, how does an error propagate, right? So first what we'll consider is, we'll consider a value, right? Z equals a plus b. So here you are going to add two values. This is just a normal addition. But in physics consideration, whenever you have a value, you will obviously have error into it, right? So I'll have to consider that error also, right? So here what I'm about to do is I'll consider a as a plus or minus del a. Okay, so you have an a and then plus or minus del a. Here plus or minus del a, this del a is going to be the error that is in the real value, which is the a mean, that is going to be capital A in this situation, right? So here I have found a plus or minus del a to be the first measurement. Same way the second measurement is b plus or minus del b. Okay, so these two are the things that you should know. Then what we are going to do is we are just going to add these two values, right? So when we add these two values, let's see what happens to the errors, fine? See here, I'll do it in variable thing. Okay, I'll consider everything to be variable and then I do the addition and all those stuff. Same way, I'll have an experimental understanding also. Okay, so we'll give numbers to it and then we'll find the logic behind the errors in the way it gets propagated. Okay, so that too will be done, right? So I'll have a small measurement thing and then we'll add those things. From that value, we will be able to understand the variable thing that we are about to get from this equation, right? Okay. So first what we do is we just add a plus or minus del a. So that is the first one, right? Then we are going to add that value with the second measured value, which also has an error into it, which is like b plus or minus del b. Okay, so here the operation is addition. So when we add those things, what is going to happen is we just do the inner multiplication, the same thing, right? So when we do the inner multiplication, what actually happens is this plus gets multiplied to the b, right? So you'll have like a plus b, right? That is what I have written here. So you'll have like a plus b. That's the first part, right? So the second part is plus or minus del a, that comes straight away into it, right? This is an addition, therefore you don't have sign change. So you'll have the same thing again, right? So you do the inner multiplication, you'll get plus or minus del b. So that is the second part, fine. So when you rearrange this, you will have like a plus b, that is going to be the a plus b. Now I take plus or minus b as a common thing, okay? So I factor out plus or minus from del a plus del plus or minus del b. So the value that you get inside this equation is del a, okay? You factored out plus or minus, therefore you'll have only plus into the bracket. So you'll have like plus del b, okay? So del a plus del b will be the error. Well, while you add these two values a plus b, so you'll have like del a plus del b. So that is how the error propagates, which means when you do addition of two values, what actually happens to the error is it gets propagated in addition itself, okay? So the error also gets added. That is what this represents, okay? This is something that you should be able to understand. So let's have a numerical understanding of it, okay? So logical understanding to it. So first what I do is I consider a rod that is having a length of 10 meter, okay? So 10 meter, let's consider that to be an AME, which is the real value here, okay? So first consideration is done. Then what I do is I have error into it. So I'll consider that error to be like 2 meter, okay? So I've considered it a larger one, so that for an easy understanding, I've taken a larger error into this picture. But in generalized situation, you'll have like plus or minus 0.1 meter, something like that, okay? So here what I do is like, in order for quick understanding, I have took a larger value that is going to be plus 10 plus or minus 2 meters, fine. So 2 meters is quite a larger thing to consider, right? So 10 plus or minus 2 meter. Then for the second rod, what I do is I consider the length of it to be like 5 plus or minus 1 meter, right? So for the first rod, that length is going to be 10 plus or minus 2 meter, which means you can have an error of 2 meters plus or minus. Same way in the second situation, the length is 5 and then you can have an error of plus or minus 1 meter, right? So now what I'm about to do is I'll consider the extreme situation, right? So in the first case, the extreme situation is 12, right? So in the first case, the extreme situation is going to be 12, okay? Right? 10 plus 2 is the 12, okay? Same way in the second consideration, I consider the extreme maximum situation, that is 6 meters, fine? So these are something like, you give it to a student, then he is going to measure the length of that rod. When he measures the maximum value that he can get, so that there is no error in that measurement, okay? So it is inside that error range. That will be like 12 meters. That is what I've taken in the first consideration. Same way in the second consideration, I will take it as 6 meters, fine. Those are the maximum thing that I've considered here. So when I add those two things, I'll get 18, okay? Right? So let's consider the second situation. Let's make it this way. The second situation is the lowest minimum thing that I'm about to take here, okay? So the minimum value that I can get is 10 minus 2, which is going to be 8, right? For the first situation, I can measure the lower, I can measure with an error into it, like 8 meters is considered as a correct value. Therefore, I'll consider that minimum value, which is 8 meter, okay? Same way in the second situation, that will be like 5 minus 1, which is like 4 meters, right? So that is the second situation. So in second situation, if I add those two values, I'll get like 8 plus 4, which is like 12, okay? So in second situation, the answer is like 12. Now what I will do is I'll consider these two values, right? 18 and then 12. After addition, I'll consider the final answer, and then I'm about to fix how far the range can vary, okay? After doing all those error things, I'm going to consider how far the errors can vary in this situation, right? Okay, so in the first one, I got the answer to be 18. In that situation, I considered the value to be maximum, okay? So I considered all those error to get added with them real value, and then I took the value to be the greatest one, right? So in that situation, I got the answer to be 18, okay? So when I get the answer to be 18, the same way I'll put it into this thing that I've got in the final situation. So here what I've got is, from the variable calculation that you have made, I have like a plus b, so I'll have to add a and then b straight, right? That is how the addition is. So I'm going to do that thing. So a plus b is going to be like, something like 15, right? So plus or minus, I'll get the second term to be 1 and then 2. So 1 plus 2 is going to be 3, right? So 15 plus or minus 3 meter. That is what I'll get, right? So the value that it can fluctuate, the answer can fluctuate is between 18 and then 12, right? So 15 plus 3, the maximum value could be 18. Same way, the minimum value could be 15 minus 3, which is like 12, right? So here, as I have predicted, so plus or minus 3 meters is the error that it could actually propagate. So that is how much it can become after doing the addition, right? So that is what the result that I got here using the numbers. So the maximum error is going to be like 18. That is what I have got here when I took all those values to be maximum, okay? Measured values to be maximum. Same way, when I took all the measured values to be minimum, which is like 8 and then 4, I got the lowest thing to be like 12 after doing addition. That is what I have got here straight away, which is like 15 plus or minus 3 meter, right? So you should able to understand this one, right? What I've done here is something that you should be able to understand, right? So next, what I'll do is I'll do it for the subtraction. So for subtraction, z equals a minus b. Here for addition, it's like a plus b. Same way, it is going to be a minus b, right? Then including the error, I'll get something like this: a plus or minus del a minus b plus or minus del b, right? As usual. Then now I'm about to do the inner multiplication. So when I do the inner multiplication, I'll get like a minus b. Okay, right? I got that one straight away, a minus b. Then for the second inner multiplication, what I do is like plus minus becomes minus plus, okay? So it gets flipped. Again, it is the same thing, plus minus, right? So for the second one, I'll have something like this, minus plus, right? So when I do the inner multiplication, you get again the same, plus minus, or the other way around that I'm about to tell is like minus plus, right? Fine. So then what I do is I factor out plus minus from this a plus or minus del b, right? So when I do the factoring stuff, I get a minus b plus or minus, I took it away from the bracket, so I got like del a plus del b, right? So here too, what actually happened is the error got added, right? So for both, as I have already told you, for both addition and then the subtraction, the error will get added. That is the result that we have got here, okay? So inside the bracket, the errors got added for both addition and the subtraction, okay? So let's have a thinking the same way that I've done here, okay? So some practical understanding. So let's do it. So I'll take the same above consideration. So I'll just, in the second situation, what I do is I'll subtract this one, right? So when I do the subtraction, what will I get? I'll get like again a minus b. So when I do the subtraction, a minus b is going to be like 5. So that is 5 plus r minus, the error should get added, right? So when the error gets added, I'll have the same value, which is going to be plus or minus 3 meters. Fine. So this will be the final answer here, right? So I should get the same answer when I do the combination with the numbers, right? So for the first situation, what I do is I take, as usual, I take a greater value, okay? So the greater value is going to be 12. That's the first consideration. So I'll take the greater value, which is like 12. Same way, I'm going to subtract here, okay? So in this situation, I'll subtract it with the lowest value that I'll get in the second case, fine? So what I do is I'll just cross flip it, okay? So I'll just match it in a crossed way. So when I do that one, I'll have like 12 minus 4 for the first condition. And then for the second condition, same, I'll have to cross match it. So when I do that one, it's like 8 minus 6. Okay. So what will be my answer? The first answer is like 12 minus 4. When I do the subtraction, I'll have like 8. So that's the maximum value which I could get. Same way, the minimum value is like 8 minus 6, which is going to be 2. Right? So the value can fluctuate between 8 and 2. So the answer that I'm about to get can fluctuate between 8 and 2. That is what this represents. Okay, let's verify with the equation that I've got. So it's going to be 5 plus or minus 3 meter. For the first situation, it's like 12 minus 4. So when I do the subtraction, I got like 8. Same way if I do here, 5 plus 3, that's 8, correct. I got it straight away. Same way, 8 minus 6, that's going to be 2. So when I do the subtraction, it's going to be like 5 minus 3, that's 2 meter, right? So in those two situations, I got the answer straight away, right? So both for addition and subtraction, what actually happens is error gets added, right? So this is something that you should know, right? You should be clear with how does an error propagate. Propagate actually means how does an error flow, something like that. So it propagates in an additive way for both addition and then subtraction, okay? That is something that you need to know. So next we will see how does an error propagate in multiplication and then division. So same logic, we could actually straight away apply it for the powers, right? So next we are about to see propagation of errors for multiplication and division. For multiplication, we'll get the equation to be z, which is equal to a into b, right? In the left hand side, as usual, I'll add error to it. Same way in the right hand side, I'll add error for all those individual measured value, right? So here left hand side will have like z plus or minus del z after doing the error thing into it. Then I'll have like a plus or minus del a multiplied by b plus or minus del b, right? So then what I do is I do the inner multiplication, right? So in this situation, as I do the inner multiplication, I'll have like ab for the first term. I have written it straight away. Same way for the second term, I'll have like a plus or minus del b, right? So I'll have like plus or minus a del b, right? Then I'll have like del a b, which is going to be del a b plus or minus del a b. Then I'll have like plus or minus del a del b, right? So now I did the inner multiplication thing here. So here, so it becomes complicated. In last situation, I was able to match straight away those errors, but in this situation, you have multiple del A and del B into it, right? So we have like three terms which has like del B errors into it. One term has only del B, the other term has del A, and the last term has both del A and then the del B, right? Okay, so here what I do is I'll consider relative error. Okay, so that is when it will get cancelled out. So you will get to know. So in the first step, in the left hand side, I'll divide it by z, okay, which is like ab. Same way on the right hand side, I'll divide it by ab. Okay, now I divided it by ab, right? So what I do is then I split all those terms. Okay, so when I split all those individual terms, I'll have like z divided by z, okay, which is going to be 1. So I'll have like 1 plus r minus del z by z, right? So that's the left hand side which you should know. Then on the right hand side you'll have ab divided by ab, okay, and then plus minus a del b, okay, divided by ab. So that's the second term. The third term is like plus or minus del a b divided by AB, and the fourth term is plus or minus del A del B divided by AB. Okay, so now I have splitted all those terms. Let's do the cancelling stuff. So when I cancel it out, for the first term it just gets cancelled away straight away, and then you have like 1 left within it, right? So you'll have 1. Okay, so here too what happens is actually on the right hand side you have like 1, same on the left hand side you have like 1. Okay, so both are in the addition stuff, therefore it too gets cancelled out, right? So plus 1 and then the plus 1, as they are on the opposite side, so plus 1 and then the plus 1 will get cancelled out, right? So the first term gets nullified. So let's look into the rest of the terms. So in the second term, what actually is common is like a and then a, so a it will get cancelled in the second term. Same way in the third term, b it will get cancelled. So what about the fourth term? So what I do with the fourth term is actually consider it to be negligible, because you are going to multiply two errors into it. Okay, error is something that's already a lowest value. Okay, so when you measure a value that is going to be like plus 10, then the error into it is like 0.1 or 0.01, right? So it is already a negligible quantity. Okay, so in that situation what I do is I have a negligible error in the first measured value. Same way I do have a negligible error in the second measured value. Let's consider it to be this way. So for the first one it is like 0.1. Same way for the second error it is going to be 0.01. So when you do the math, when I multiply it, what I get is like 0.001, right? So the error, when you do the multiplication of two lower value, actually what happens is it goes still lower, right? So in that situation, del A del B is considered very less. Same way, after considering this del A del B to be lower value, then what I do is I divide again it with the multiplication thing of the AB. Okay, so here del A del B in itself is least, and then I do division to it. So overall I'll consider this entire term to be negligible. Okay, so this equation will be valid. I'll be able to consider the fourth term to be negligible only when the error in the measurement that I've made is lowest. Okay, in that situation I'll be able to consider the fourth term here as a negligible one, right? Therefore the fourth term here is negligible. Okay, so now I did consider the fourth term to be negligible. Then it's time. Okay, so the only term that I'm left with is the second term and the third term. When I consider the second term and then the third term, what I do is now it's time, right? Now I'll be able to get the error into it, which is going to be my relative error, because the only thing that I have in the left hand side is del z by z. So you'll have like del z by z plus or minus del z by z, which is equal to plus or minus del a by a. Same way, you'll have like plus or minus del b by b, right? So this is equal to plus or minus, okay, I factor it out, then I'll have like del a by a plus del b by b. So in multiplication, what actually happens is relative error gets added, right? So in addition and then the subtraction, errors straight away it got added, but in multiplication, what it did actually happen is the relative errors got added. That too, I consider the fourth term to be negligible, okay? So for the multiplication thing to work out correctly, what I should consider is, I should consider the fourth term to be 0, which means the error in the measured value is so small that when I do the multiplication, it becomes extremely small, and then when I divide it by AB, it becomes extremely small, okay? Again, it goes to the lowest value, right? So that term could be considered as negligible, right? Okay. So now you should be clear with the multiplication one. Then we will see what is meant by division, right? So in division, the same way, I'll consider it to be like A divided by B, right? So in division also, you should get the relative errors to get added, right? As I've already told, for multiplication and division, we'll get into the same result. That is what we'll get in this equation, in this stuff also. But the thing is, we'll do like two approximation in this situation. Let's see what all are those things. Fine. So the first one is, obviously, z equals a by b. That is how we'll consider, right? So for the left hand side, I'll have to put an error into it. So that's going to be z plus or minus del z, the same step that you have done for the multiplication. And then in the right hand side, what actually happens is a plus or minus del a divided by b plus or minus del b, right? Fine, that was correct. Then what I do is I just factor out a and then b, okay? From the numerator, I factor out a, and then from the denominator, I factor out b, okay? So when I factor out a from the numerator, I'll have 1 plus or minus, okay? As I do the factor out stuff, I'll have like 1 plus or minus del a divided by a, right? So in order to compensate that a, I multiply, I divide by a in the second term, right? So you'll have like del a divided by a. So that will be my numerator in this case. I'll do the same thing with the denominator. When I do the same thing with the denominator, I'll have like I factor out b. Then inside that term, I'll have like 1 plus or minus del b divided by b, right? So here, now I have done the factoring stuff. Then what I do is, I divide the first term by z, okay? Which means the left hand side by z. So that is what I have done with the multiplication also. So I do the same thing here. So as I divide the left hand side by z, what I do in the right hand side, also, I divide the complete term by z, which will be like a by b, and the numerator also will have one a by b, right? So when I cancel out both those a by b and then a by b, so in the right hand side, what actually happens is both those a by b will get cancelled, okay? Same thing that happened here, right? So in the left hand side, what happened is z divided by z, that's going to be like same way 1, and then del z by z will be like del z by z, fine. So now what I have to do is I'll have to consider this equation, right? I'll have to do the inner multiplication in this situation. That is like complicated, fine. So because you have -1 in the second case, right? If it was like +1, that is not a problem, okay? That was the case in the multiplication, but that's not the case in the division, right? You have power that is equal to -1, right? So this is like inverse thing. In order to make this power a positive value, what I do is I use like binomial theorem, fine. So we don't see the mathematical proof behind the binomial theorem. That wasn't useful. Only thing that we are about to see here is the application of it, okay? So what is meant by binomial theorem and how to use it, right? So this is actually an approximation method, right? So I'm about to apply the first approximation, okay? So second approximation is just the same thing that we have done with the multiplication. So the first approximation here is the binomial theorem that I'm about to apply here, okay? So this two thing will work only when you have del b, which means the dividing term, error in the dividing term is going to be small. So in that situation only, this binomial theorem will be able to use it, or else you'll have like considerable deviation into it. So same way, when I consider this binomial theorem, this is actually an infinite series, fine. So as this is an infinite series, you'll have to consider all those infinite terms to get an accurate value, okay, to get the same value. But in this situation, that's not the case, right? So we are about to do the first approximation. So in that first approximation, the things will be such that I'll consider the first two values, okay? So the binomial theorem for this one is actually like 1 Okay, I'll consider the first term. If it was like 2, I'll consider it 2, right? So here the first term is 1, so I'll consider the straight away that to be 1. So the next one I'm about to consider is like I'll multiply the power to it to the x. Okay, so I'll multiply the power to the x, and then I'll get the second term, which is going to be nx. Okay, the next term here is going to be like n into n minus 1. Fine. So I'll consider this n. Oh, okay, if it was like 3, then I'll have to put 3 here, and then 3 minus 1, which is going to be 2. Fine, divided by, so you'll have like divided by, as this is the third term. Okay, for the first term I took the straight away that one which is inside the bracket, the a, which is like 1 here, and then for the second term I divide it by 1. For the third term what I do is I divide it by 2 factorial. Okay, so 2 factorial actually means 1 into 2. Okay, so in this situation for the third term I took 2 factorial. Same way for the fourth term I'll take it as like 3 factorial, which means 2 into 3. Okay, so for the third term, I took it 2 factorial. Same way in the numerator, you'll have like x square. Okay, as it is the third term, you have like x square, and then this series goes on. Fine. So it goes on until n minus 1 becomes 0, right? Until it becomes like, let's make it this way. If it was 3, so you'll have like n into n minus 1 into n minus 2. So for the next term, we'll have like n minus 1, n minus 2, and then n minus 3. So 3 will get cancelled. So the fifth term in that situation is going to be 0. Okay, so this thing keeps on propagating until n into n minus 1 becomes 0. Okay, so until then this term keeps on repeating. Here what I'll have to consider is only the first two terms. I'll consider just the first two term, and I'll consider the third term to be 0. Okay, so here the third term is actually 0, right? So when will I be able to consider this third term to be 0 is when I consider this x to be small, so small, right? The x here in the situation is del b by b, right? So when you consider that x to be small, which is like 0.1 or 0.01, and then x square is obviously small, right? 0.01 times 0.01, and then I 2 divided by 2. Okay, then you have some small number to be multiplied in front. So in that situation, the numerator here is extremely small, so obviously this term is going to be very small, which means I can consider the third term to be negligible, right? Same way the next term that are about to come is like x cube and those things, right? Fine. So the next term here will be like n minus 1, n minus 2, and then x cube divided by 3 factorial. Obviously x cube is small when compared to x square itself. I'll consider the rest of the terms to be negligible. Fine. So in this situation I took the first two terms because rest other terms are negligible. So that is the first approximation thing that I've made here. So for applying this binomial theorem, what I've done is I took an infinite series. Okay, the only thing that was matter is the first two terms. Okay, I don't wish to consider the rest of the terms because I consider it to be negligible. From that, first two terms is considered, right? So what actually happened with the first two terms, it is something like this. The constant, the first term was directly taken, which is 1 in that situation, and before the second term I am about to multiply the power into it, right? So I'll have the second term to be plus nx. Okay, so that is how I'm going to apply this binomial theorem into this above equation, right? So when I do apply that binomial theorem, what actually happens is, so first term will be unaffected, so you'll have that one straight away, which is like 1 plus or minus del a by a. So for the second term, what I'll have to do is I'll have to consider this power and then I'll have to multiply it, right? So for the second term, this will be my x, and then I'll have to multiply this x with the power, right? So the power is going to be negative 1. So when I do the multiplication, I'll get like 1 plus nx. So I'll have like minus del b by b, right? So when I do the multiplication, plus becomes negative and then the negative value becomes positive, right? So here for the second term, only thing that is about to happen is that sign gets flipped, right? So when that sign gets flipped, you'll have like minus plus, right? So this is something that you should know. So now I have applied binomial theorem into it. Then what I do is I cancel out all those thing that you have into it. Okay, same thing, I'll get cancel it out. So here for cancelling it out, I'll have to do the inner multiplication. So when I do the inner multiplication, I'll have like 1 times 1. I get the same thing again, which got cancelled. Fine. Same way, what I've got in the multiplication, I'll get the same thing again. So 1 it will get cancelled out. Same way when I do this for the second part, I'll have like del a, right, del a by a, and then you'll have like plus or minus del b by b. So that is something that got repeated. So when you do the multiplication for the fourth, to get the fourth term, you'll have like plus or minus del a del b by D, right? So this is the fourth term that you are about to get. So obviously in the above situation also, in multiplication I took del A del B times A by B as an divided by AB as a negligible parameter. Same way I'll do the same thing here. You got the same thing here also, which is like del A del B divided by AB. So that term could be considered negligible, right? So here also the fourth term is considered negligible, right? Okay, fine. You should be clear with this one. Then you have like plus or minus del Z by Z. Again, you have plus or minus. I'll factor that one out. Then you'll have like del A by A plus del B by B, right? So here what actually happened is relative error got added, right? As I expected, relative error got added, right? For both multiplication and then the division, what actually happens is relative errors get added. That is what I've written here. In multiplication and division, relative error gets added, right? You should know this one. There shouldn't be any doubt into it. Next, we will see for powers, right? Here we have like z equals a square, right? So that is how the power is going to be. So I'll be able to write this power as a into a, right? Fine. So here these two things are in multiplication. So for multiplication, what will I have in the errors? Though their relative errors get added, right? So for multiplication, the relative error will get added. Here both is the same thing, del a by a plus del a by a. So both will be the same thing for multiplication. So when the relative errors get added, I'll have the answer to be 2 del a by a. So when you get power, what you actually have to consider is you'll have to consider the power and then multiply it with the relative error. Okay, that is what we'll do, right? It's the same thing, right? Because both are the same term. So del a by a and then del a by a, you'll get the same term again. So the relative error gets added. Therefore, the answer is going to be 2 del a by a, right? So this is how the error propagates for powers the same way it had happened with the multiplication. Okay, so let's complicate stuff a little bit. So you have z equals a square b cube and then c square, right? So what will happen to the error? It will get relatively added. So what I have to do here is I'll have to take the power and then multiply it with that particular relative error, right? So for the first one, for a, the relative error is going to be del a by a, and then I'll have to multiply the power to it. So you'll have 2 del a by a, right? So then for the second term, which is like b cube, I'll have to multiply it by the 3. So I'll have like 3 del b by b, right? Then for the third term, which is like the denominator division one. So even in division, the relative error has to get added. So even for the division, I'll have to put the plus sign. So you'll have like plus the relative error here is 2 del c by c, right? So the relative error got added. Okay, so this is something simple, right? This is directly related to multiplication and division. Therefore, I got the answer straight away in the situation, right? So then we will do some unit conversion thing. Okay, so we'll do the unit conversion between meter, decimeter, right, centimeter, millimeter, and all those things we'll consider, and I'll do that unit conversion. Okay, so these conversions are something that you should know because we'll get questions from these kind of conversion. Okay, so they'll give the question in centimeter and then I'll be in a situation where I'll have to change it to meters or else I'll have to change it to some other units. Okay, so these are something that you should know. So the first one is like the conversion is always from the meter. So I'll consider meter to be my standard thing. From that, I'll do the conversion. Okay. So the conversion is for like decimeter, centimeter, and then the millimeter. Okay. In when you do the conversion from meter to decimeter, what happens is 1 meter equals 10 decimeter. It seems to be like a multiplication thing to it. So I'll have 1 meter to be like 10 decimeter, right? So when you move from meter, which means upwards, you get multiplied, right? I just move here in upward fashion. Okay, so the first upward movement, I'll have like d 1 meter to be 10 decimeter, right? Okay, you should know this one. So then for the second step, which means from decimeter to centimeter, I'll have to multiply it again by one more 10, right? So for the first movement, I'll multiply it by 10. For the second upward movement, I'll multiply again it by 10. And then for the third, it's the same thing. So I'll multiply it by 10, right? So for the first situation, I got to be like 10 decimeter from 1 meter, which is equal to 10 decimeter. Then what I do is I move from 1 meter to centimeter. Okay, so 1 meter will obviously be equal to 100 centimeter. Okay, so from 1 meter to 100 centimeter. Okay, this is something that we know itself. Then from 1 meter to millimeter, so that will be like 3 steps upwards. So it is going to be 1000 millimeter, right? So I have made the conversion for upward movement, okay, hierarchical upward movement. Same way, if I move downwards, what will I get? For the downward thing, I'll have to divide, right? So 1 meter, then comes the decameter. So I'll divide it by 100. I mean, like, I'll divide it by 10. So we'll have like 1 by 10. So 1 meter equals 1 divided by 10 decameter. Okay, I'll have like 1 by 10 decameter, right? Then for the second movement, right? So we have another one term in between which is not needed. Then the final thing that you should know is for kilometer. This is obvious, right? 1 meter equals 1000 kilometers. So here I'll multiply it by 1 by 1000, right? For that moment, I'll multiply it by 1 by 100. Above, it's going to be like 1 by 10, 1, 10, 10, 10. So for the downward movement, first one is going to be like 1 by 10. Second one is going to be one more 1 by 100, which will be like 1 by 1000. Okay. If I if I consider that together, I'll have like 1 by 10 times another one 1 by 100, which is going to be like 1 by 1000, right? So for kilometer, that conversion, I'll have the answer to be 1 divided by 1000 kilometer, fine, which means 1 meter equals 1 by 1000 kilometer. If I move other way around, which means from 1 kilometer to meters, then it is like moving upwards, right? So if I move upwards, which means like 1 kilometer equals 1000 meter. That is how I get. Okay, here I put meter as my standard thing, and then I just made an upward movement and then the downward movement, hierarchical movement. So when I move upwards, I multiply it by 10. Same way, when I move downwards, I divide it by 10 or hundreds. Okay, whatever happens, if I take kilometer, the bottom value, and then I move 2 steps upward to get meter, what I'll have to do? 100 into 10. I'll have to do the multiplication thing here, right? So because I come from the bottom and I move upwards, therefore I'll have 1 kilometer, which is equal to 1000 meter. That is how it should be, right? Here I have considered one question, which is the movement from decimeter to meter. The conversion is from decimeter to meter, right? Here I move downwards, right? I move from decimeter to meter, which means 1 step downwards, right? So when I move downwards, what I should do? I'll have to divide it by 10, right? If I move upward in this situation, I multiply it by 10. If I move downwards, I'll divide it by 10, right? Only for this decameter to kilometer, I'll divide it by 100. In rest all other situations, it's going to be like 10. Fine. So here I just move 1 step downwards, which means from decimeter to meter. So what should actually happen? I'll have to divide, right? So 3 decimeter equals 1 by 3 by, if it was like 1, that's going to be 1 by 10. Here in the situation, it's like 3. So 3 into 1 by 10, which is going to be like 0.3 meters. Fine. So the answer for this question is should be like 0.3 meter, right? So we should be clear with this unit conversion. This is how we'll do those conversion, right? Here decimeter, that's above, and then meter is below. So I'm going 1 step downwards. So when I move like 1 step downwards, I'll have to divide it by 100. Whenever I move upwards, I'll multiply it by 100. Same way, when I move downwards, I'll have to divide it by 100. Therefore, the answer is going to be 0.3 meter. Okay. So these are the unit conversions that you should know related to length. Fine. So rest other units and all, we will do it as we look into those chapters. As if now, these length unit conversions is something that you should know, right? So next, we will see significant figures. Significant figures. Fine. As I have already told you, significant figure means what all are the numbers that you'll have to consider while doing an experiment. Okay. So let's see what all are the rules that are into it. The first one is non-zero digits. Okay. So I'll have to consider all non-zero digits to be significant. Okay. If it is like 1, 2, 5, 7, so all those 4 digits is significant, which means in this situation I'll have like 4 significant figures, right? Let's make it this way. 1257, it is measured in centimeters. Okay, so 1257 centimeter. Then if I do an unit conversion from centimeter to meter, I'll have to divide it by 100. Therefore you'll have 12.57. So while doing unit conversion also, you'll have those 4 digits to be significant. Okay, so those 4 values are exact. That is what it represents. Fine. So non-zero digits are considered significant, which means in this situation 1257, there are like 4 significant figures, right? Then the second condition is zeros between non-zero digits are significant, right? So here you'll have 2005, so 2005. So zeros are in between. In that situation, those zeros should be considered. You should have like 4 significant figures in this situation. Therefore, the significant figures in this situation is like 4, right? You should know these things. So non-zero digits are considered to be significant. Same way, zeros between the digits, non-zero digits are considered significant. Okay. So let's see what is the third rule. The third rule is when the number is less than 1. Okay. When the number is less than 1, starting zeros are insignificant. Okay. So here it is like 0.0034, right? So here the significant values are only 3, 4. Those two values are significant. Therefore, the significant figures here are, you just have only two significant figures, right? So the reason behind this, let's consider this to be in meters. Okay, here I have measured it in meter, which means like 0.0034, right? Only these two values are considered to be significant because when I do the unit conversion here, I'll have like, let's make it this way, I'll convert it to centimeters. So when I do conversion from meter to centimeter, it's like moving upwards. Therefore, I'll have to multiply it by 10, 2 tens. Therefore, I'll have to multiply it by 100, right? So you'll have like 0.34 centimeter, right? So here these zeros shouldn't be considered because of the unit conversion, I get that zero, not because it is significant, right? Therefore, only 3 and 4 are significant figures here. Therefore, you get two significant figures, right? So you get the answer to be like 0.34 centimeter. And then when I do again one unit conversion for millimeter, I'll have like 3.4 millimeter, right? So here that zero is also gone. So only these two numbers are significant. Okay. So now you should get an idea why I consider the numbers alone to be significant, because those numbers will be constant irrespective of the unit conversion that you make, right? So when you do unit conversions, you will add zeros into it. So those zeros are insignificant. That is what the significant rule actually come into picture, right? Fourth rule is zeros after the decimal point are significant, right? So let's see an example, 30.00. In the situation, right, 00 after the decimal point, you have two zeros, that is considered as significant, which means the zero before the decimal point is also significant. Okay. So here 30.00, in this situation, all those four values are actually a measured value. Therefore, we'll have to consider all those value to be significant, right? So we'll see another one example here. With that, you'll be able to conclude the logic behind it. Fine. So here 30.00, right? In this situation, you will be having four significant figures. So from the rule, it is clear zeros after the decimal point are significant, right? So let's consider a situation. For example, you are going to measure a length. In the length of that one is going to be 3000 centimeter, right? So three double triple zeros. Okay, it is triple zeros are valid zeros because when you measure that length, you got like the 3000 centimeter, right? It could be like 3000.25 or 0.23. That is something that we didn't measure, but three, after three, you're going to have like three zeros. That is what this clearly signifies, right? So in this situation, in physics, we should not write this way, this in this notation 3000 centimeter, because we didn't specify the significant figures properly. Therefore, how we should actually write this one is 3.000 into 10 power 3 centimeter. That is how I should write. Okay. So when I put a decimal place, it clearly indicates all those zeros that comes after the decimal place are significant, which means I have measured it, right? So if I have to write it in centimeter, how should I actually write this? 3.000 into 10 power 3 centimeter. That is how I do write this one. In that situation, these four numbers are significant. That is how I told 30.00 is a significant figure, right? So now what I'm going to do is I'm going to make an unit conversion from centimeter to meter, right? So when I do unit conversion from centimeter to meter, what I should do? So 1 centimeter actually equals to 10 power minus 2 meter, right? So you'll have something like this, 30.00 into 10 power minus 2 meter. That is how you write. Fine. But in physics, how I do write is I just put only one decimal places, right? I just consider only one value to be before the decimal places, then rest all others should be after the decimal point. Okay. So in that situation, 3.00 into 10 power minus 1, because you'll have like 10 power minus 2 meter for 30.00. But generally I used to put decimal place after the first number. Therefore, you should get 33.00 into 10 power minus 1. Okay. So 10 power minus 2 times 10, because I have increased one place. Therefore, I should multiply it by 10. Okay. In order to match that one, right? You should know this one. Therefore, you got like 3.00 into 10 power minus 1 meter. So in this situation, all those three numbers, after all those three zeros after the decimal place are significant. Okay, that is why I have notated in this fashion, right? You should know this one. Same way, let's consider speed of the light, right? So there is another one situation where it becomes pretty more clear. Speed of the light. Okay, when we measured the speed of the light, the answer was something like this, 299,792, some large number, right? So here you got around like 8 numbers here. So this is the exact number, but we do not know what the number actually is after the decimal place here, but these are measured values. Okay, so these 8 numbers are significant, right? But generally in the sum, if I have to put such a huge number, it is hard to do the mathematical calculation. Therefore, I'm going to approximate this number. The way I am going to round off this number is like 3. I'll consider only the first two number and I'll round it off. When I do the round off thing, I have like 3 into 10 power 8, right? So the real answer is something like this, but I rounded it off and I got 3 into 10 power 8. Okay, I shouldn't be able to write this one as 3.0 into 10 power 8 because after this point I get a 0, which is like significant figure, right? So I should write 3 into 10 power 8, which clearly represents that there is like one significant figure in this situation. Okay, so after I round it off, I just got one number, so that is the only number which is significant here. Therefore, in 3 into 10 power 8, the significant figure is actually equal to 1. It should be clear by this time what is meant by significant figure. Okay, the purpose of significant figure is actually when you make unit conversion from one unit to other, the number that is not going to change is considered to be the significant figure, right? So here zeros after the decimal point are significant. That is the rule that we have given here, right? If I'm going to write 3000 centimeter, then in this situation, obviously this is wrong. You shouldn't write it this way. You'll have to put a decimal place. Fine. So the fifth point that I'm going to see now, the fifth rule that I'm going to see now is actually the outcome of this fourth rule, right? I shouldn't write 3000 centimeter. If I'm about to write these three, like 3000 centimeter, then it actually represents the last three digits. Zeros are insignificant. Okay, that is what we are going to see now. Trailing zeros are insignificant, which means only if I put a decimal place, that zeros become significant. If I didn't put a decimal place, then those are considered as trailing zeros, which are insignificant. Okay, the zeros that comes after the number, right? If the zero is in between two significant figures, then the second rule that we have seen, if the zeros is between two significant figures, then that zero should be considered as significant, right? But in this situation, the trailing zeros, the zeros that comes after the number, right? So those are considered as insignificant, right? If I write it like 3000 centimeter, which means just one number is significant. So here you have a number 30700, okay, 30,700 centimeter. Okay, so here in this situation, only three numbers are significant because I don't have a decimal point. Only if I have a decimal point, it represents those numbers are significant. Here it is just a number without decimal point. Then it could have been, these zeros could have come because of that unit conversion. Therefore, the zeros are insignificant. In physics, you should be clear, zeros that comes without decimal places, okay, after the number are considered insignificant. Okay, so in this situation, the significant figures are just 3. So here you have 3 significant figures. Last two zeros shouldn't be considered as significant figures, right? So same thing here. Let's make it this way. If it is like 30700 centimeter, if I convert it to meter, I'll have like 10 power minus 12 multiplied with 10 power minus 2. Therefore, I'll have like 307 meter, right? Only these three number pops up again. Same way, if I'm going to convert it to decameter, in that situation, it's going to be 30.7. So those three numbers should come into picture. Zeros shouldn't be considered. If I'm going to write it this way, 30.700, which means these two zeros are also significant. That's not the case here. By this time, you should be clear with significant figures. Okay, there are like 5 rules which you should know. The first one is all those non-zero digits are significant, right? That is clear, right? Same way, if there are zeros between the two significant figures, which means between two numbers, then obviously that zero should be considered, right? The third rule is if it is less than 1, the zeros before that number are considered insignificant because that might have come because of the unit conversions, right? Therefore, those zeros should not be considered, right? Then comes the tricky part, which is like zeros after the number. Okay, so in order to get that one right, what we do is generally when you write an answer in physics, while doing an experiment, how you should write is, you'll have to write the number. The first one should be before the decimal point, just one number. Then you place a decimal point. Then after that, you write rest all other significant figures number. Then you just put into 10 power what the power that you need to put, right? So that is how you're supposed to write the physics answers, right? So that is what I've given in option. That is what we dealt with rule number 4. The rule number 5 is the continuation of the rule number 4. If I'm going to put zeros after a number without any decimal places, which means there is just unit conversion which has been made, therefore you shouldn't consider that to be a significant figure, right? So these are the things that you need to know about significant figure. Then let's move on to rounding up. Now I need to round off the values, right? So these are like simple things that you should have already known in your lower grades itself. That is what we are supposed to see here. So if a number is less than 5, let's make it this way, 7.32. I need to round off this number. So just to 2 digits, okay? If I need to round off this one to 2 digits or one decimal place, what I do is, it is less than 5, therefore I shouldn't raise that number 1. I should consider that to be the same number, right? So here I'll have like 7.3 as my answer. Fine. If the number is greater than 5, okay, in that situation it's like 7.36, then I'll have to raise the before number by one value. So you'll have like 7.4. Okay, this is something that we know. Same way, if it is equal to 5 and the number is like odd, okay, the before number is like odd, then I'll have to raise it. So I'll have like 9.4. These are just the convention. These are just the way it is set. That's it, finished. Okay, there is no logic to it. Okay, the next one is 9.65. In 9.65, if I raise the before number by 1, then it becomes an odd number because in itself is an even number. Therefore, I'll have to consider it straight away, which is going to be like 9.6, right? So this is how you do the rounding of stuff. Then comes the addition and subtraction. So when you are about to do addition or subtraction, how should I consider the significant figure? First, let us do the addition thing. Okay, so here let's subtract it or add it, whatever it is. So when I add that's this stuff, I get like 7, fine, 5, 0, 1, 5, 15.057. So that will be my answer, right? Here, how many numbers should I consider? So in order to consider this one, the rule is like consider the least number of significant figures after the decimal point. So here I should consider significant figures after the decimal places, right? So in the first one, I'll consider significant figures, that is like 3. 1, 2, 3. There are like 3 significant figures in the first one. Same way in the second number, I have like 2 significant figures, okay, after the decimal places. So what I should do is I should round it off such a way that I get least significant figures after a decimal point, right? So in the first situation, I have like 3 significant figures after the decimal place. And in the second part, I have like 2 significant figures. While considering these two things, I'll have to take the least significant figures, okay? So in the answer, I have like 3 significant figures after the decimal place. The thing that I should round off is like 2 decimal places after the significant figures, because here in the second one, I do not know what the third significant figure actually is, right? It could be 0, it could be 1. That is something that is unknown. Therefore, this value couldn't be predicted. Therefore, I'll round it up only to 2 decimal places, right? So if I round it up this one, I'll get something like this. It should be like 15.0. So 57, right? I should round it up such a way that I get 6, right? Because this number should be like even number. Therefore, the answer should be 15.06. You should be clear with addition and subtraction, how to find the answer with correct number of significant figures, right? You shouldn't have any doubt in this one. Next, we will see like multiplication and division. In multiplication and division, I should consider least number of significant figures, right? So you should consider the entire number, and then from that thing, I'll have to consider the least significant figure, the number which has the least significant figure. In addition and then subtraction, how did we actually take is the significant figures after the decimal place. That is how we consider. But in multiplication and division, you'll have to consider it such a way that a number which has least significant figure should be considered, okay? So here, if I do the multiplication between 1.21 and 36.72, I've already done the multiplication. You'll have 44.4312, right? So here, how should I round it up is by considering the significant figures in those two situations. In the first one, you have like 3 significant figures, and in the second one, I got like 4 significant figures, okay? The least one is like 3 significant figures. So from the answer, I should round it up to 3 significant figures. The answer is going to be 44.4, because this number is like less than 5. Therefore, I should round it up with the same number itself. Therefore, the answer should be 44.4, right? You should get this one. The next one is like division. So same consideration again here. 36.72 divided by 1.2. The answer will be like 30.6. You do the math, you get like 30.6. So here what we should know is how to round off 30.6, right? So when I do the round off thing, I get like I should round it off to like two significant figures. Okay, so divided by 1.2, which just has two significant figures. Therefore, I should round it up to two significant figures. Fine. So if I need to round it up to two significant figures, then I'll have the answer to be 30. Okay, but here 0.6, that number is greater than 5, therefore the answer should be like 31, right? So I did round up those two things. So you should be able to understand these things. How should we round it off while doing like multiplication and division? So while doing like multiplication and division, you consider the least significant figures considering all those number, right? Not the thing that is after the decimal places, right? So this should be clear. One time we have got question from multiplication and division. Okay, that was the simplest one. So you just do the multiplication and then round it off such a way that you get the correct significant figures. That was the question, and the answer was something like this. You should do the math and then you should round it off such a way that you get the correct significant figures, right? Okay, you should be clear with rounding of things. Then comes the final part of this session, which is going to be dimensional analysis. Dimensional analysis. Right, as I have already told you, in dimensional analysis, what we do is we will balance the units between left hand side and right hand side of the equation, right? So you should have the same units. That is when we will be able to put the equal to symbol, right? Fine. So when I do that unit balance thing, I'll make a combination in the left hand side such a way that I get the same units on both those sides. Okay, how should I do that is something that we are going to see now. Here the experiment that I'm about to take is the time period of a pendulum, right? So pendulum means you take a string and then tie a mass to one end of the string. That is the pendulum here. What I do is I stretch that pendulum to certain angle, okay, in the situation towards the right, and then I leave it. So when I leave it, it undergoes oscillation. Oscillation actually means that you have to and fro uniform motion, that is considered as oscillation. So here what I'm about to find is the time period for one oscillation, right? So time period generally means time taken to complete one cycle. So cycle here is that oscillation thing. Okay, so I just pull the string towards the right and then I'm going to drop it. When I drop it, okay, I just start the clock when it reaches its mean position. Fine. So when it reaches its mean position, I just start the clock. Fine. So it just goes to the right to the maximum position, and then it returns back to the left, and then again it comes to its mean position, right? So this is like one oscillation. We will do oscillation exhaustively in the later part of physics. Okay, the last chapters of physics in the 11th grade we'll do those oscillation exhaustively. As if now what you should know is oscillation means you just take something and then it goes to and fro motion in an uniform pattern. Okay, so when this thing goes to and fro in uniform pattern, as it is an uniform pattern, you will be able to calculate the time for that one cycle, right? So here the time for one cycle is called as time period. That is what I am about to find here, right? So this pattern is uniformly repeating pattern, therefore I will be able to get the time period, right? So in order to get the time period will be my left hand side, that is like capital T, right? Capital T generally denotes time period, small t means time, so time period means capital T, right? Okay, so then what all are the parameters that are involved here, right? The parameter that are involved here is like length of the string. I'll be able to change the length of the string. Okay, that is possible. Then what will I be able to do? I'll be able to change the mass that is hanging on the string. Okay, so the mass could be changed, length could be changed, mass could be changed. Then the final thing that we could change is the acceleration due to gravity. Fine, we'll deal with acceleration and all those things exhaustively in next chapter. As if now you should know acceleration due to gravity could be changed, but in the surface of the earth, okay, when you are close to the surface of the earth, acceleration due to gravity is just the same thing, which is going to be 9.8, right, meter per second square. Therefore I'll give you the unit straight away, as we do not know much about acceleration due to gravity. Acceleration, the unit for acceleration is meter per second square. Okay, from the lower grade you should know, but anyway we'll discuss this one clearly in the next chapter. Okay, meter per second square is the unit of g, right? So the unit, unknown unit here is like g, which is something that I've given you here. And the same way, m is going to be the mass, which will be measured in kg, right? Length could be measured in meters. Okay, so these are the SI units, right? So while doing dimensional analysis, the general rule is you'll have to put, you shouldn't put those SI units. For mass I'll put like m, and then for length I'll put like L, and then for time I'll put T. Okay, so here in order to get the unit, for meter per second square, the dimensional unit is, for mass it is like length, which will be put in L, and the same way for the time I'll put T. Okay, so here I don't consider the units, right? I don't consider it to be like second or meter, should be like kilometer. That is not something that I'm about to consider here. Only thing is, I'll consider meter to be L. Straight away I'll just match with that straight notation like capital L, and then for time I'll match it with the capital T. That's it, fine. So these are just the notations. Okay, so here I'll match it with L. Okay, and then for time I'll match it with T. So we'll have like T power minus 2. So this is the dimensional formula for acceleration due to gravity G. Okay, and then unknown here is like for length I'll be able to put, like L, and then for the mass here I'll be able to put like capital M. Right, now I have got the dimensional formula for all those unknown variables here, which is like length, mass, and then the acceleration due to gravity, right? So now what I should find is, I know the unit of time period is going to be like time, therefore it should be like capital T. That is the dimensional and formula for the time period. Same way, I know the all the dimensional formulas for right hand side of the equation, right? Now I do the combinations out of it, and then I match it such a way that I get same dimensional formula on both left hand side and right hand side of the equation, right? So let's put all those things into an equation. So when I put all those things into an equation, on the left hand side, only thing that should have power 1 is going to be the time, then all other variables should rise to 0, right? Okay, so left hand side is going to be M power 0, same way L power 0, and then T power 1, right? So that should be my left hand side here, because this is just the time period. So this is the dimensional formula for the time period, which means only you have power raised to 1 for time period, right? So next, on the right hand side you have like length, mass, and then acceleration due to gravity coming into picture, right? So for the length I'll put like L, okay, raised to A, which means power A. Same way mass, and the power of that one is like B. Okay, and the third one that you have is like acceleration due to gravity, which is meter, L T power minus 2. Fine, got it? So I have put like A, B, and C, right? I have put like A, B, and then C. The reason why I put A, B, and C, those constant are, those are the variables that I need to find here. Fine. So length is something that I know, because from the length of the rod I got that dimensional unit. But how should I combine this one such a way that I get the left hand side and the right hand side to be with the same units, right? So these A, B, and C are the unknown constant here, which I'm supposed to find here, right? You should know by this time these A, B, and C are the unknown constant which I should get, right? So what all are the units that I know? I have written it inside the square bracket. These A, B, and C are unknown, which I should find it out, right? So before proceeding into the next step, what I do is I'll combine everything. M I'll combine into a single term. There are like two length in this parameter, so I'll put it into a single term. Same way there is like one time, so I'll put it that into a single term, right? Okay. So the next step that we have is like something like this: M power 0, and then you have like L power 0, and then T power 1. So this is the left hand side, same thing. And on the right hand side you have like M power B, mass raised to B, the power is B, and then you have L, which is raised to A, and then you have LT power minus 2, right? But in the situation there are like two L's, right? As you have two L's, you just put one C into it, right? So you'll have like L power C. So you'll have, when you have like same base, I'll be able to add the powers, right? So here I will add the power, and I'll have L power A plus C. So that's the second term, right? Now I have done with the L part. Then I have like T, which is the time, right? So you'll have T power minus 2C. Fine. Now I have got all those left hand side and right hand side into a single bracket. Now I can equate the powers. Fine. So when I equate the powers, M power 0. So that is the power. So for mass on the left hand side, it should be equal to 0. Then as this is equal to, so left hand side and right hand side should be the same. Therefore, the first thing that I get is B should be equal to 0. Right. When I equate the powers, I get B, which is equal to 0. Fine, the first part is done. For the second part, I have like L power 0. So length should be equal to 0. with the power, okay? So when I consider the power, a plus c should also be equal to 0, right? So a plus c should be equal to 0. Now what I'm doing is just equating the left hand side and the right hand side. What I'm equating is, I'm equating the powers, right? Here all those base are same. Therefore, when I equate the power, I should get the same value on the left side and the right side. That is what I'm doing here, okay? You should know, you should be able to understand this one. So then what I have is like 1 which is equal to minus 2c. So 1 which is equal to minus 2c, then c equals minus half, right? Now I have got the c. If I substitute the c in the above equation, right? If I substitute this one in the above equation, I'll be able to get a. Therefore, a will be equal to a minus half equals 0. Then a should be equal to plus half, right? Now I have got a, B and C. So A is half, C is minus half and B will be equal to 0. Now I have found the answer for all those constant. So here L raised to A. Okay. So here L is the length of that pendulum. Therefore length of that string. So L power A is something like L power 1 by 2. So that is what we should get. So for the first one I'll have like L power 1 by 2. Right. So the next one is like mass, right? So mass is considered to be the mass of the bob, therefore m power b. That is how I fixed that equation. Therefore those are the unknowns. The unknown is found, so b should be equal to 0. Then b equals 0 means mass shouldn't be considered, therefore it should be like m power 0, right? M power 0 is actually 1, so that will not be considered. Then the final one is like c, which I found it to be like minus half. So c is L t power minus 2 the whole power c. That is how I took the equation. Therefore here L t power minus 2 is actually the acceleration due to gravity. Therefore for that the constant that I've got as a power is like minus half, which I should substitute it, right? So g power minus half. Fine. So if I do the rearrangement, I'll get something like this. Mass shouldn't be considered. Only thing that should be considered is the length, okay, and then it should be like half. Then root L should be considered. Same way, acceleration due to gravity should come in the denominator, fine, of that root. So T is proportional to root L by G. Now I have got the relation. So this is how we should do the dimension analysis, okay? You'll have to get the units of the left hand side. For that left hand side units, I should match the right hand side units, okay? I should make a combination. So in order to get that combination, what I do is I just put all those variables into it and then raise to some power, right? So those powers are something unknown constant which I need to find. So in order to get that constant, I put all those dimensional formulas into it and then I do the inner multiplication, which means I just club the mass together, length together, and then the time together. When I club all those things, I'll get some definitive powers, okay? So when I get that powers, I'll just match it with the left hand side powers. So when I do the math, okay, simple cross multiplication and those things, when I do the math, I'll get the values for those powers. From that power, I'll be able to get the relation between the time between the left hand side and then the right hand side, okay? So here in that situation, the left hand side is going to be the time. So with second, I was able to match the length and then the acceleration due to gravity, right? Okay, so the answer is like root L by G. That is what we have got. So when you do this experiment and then find derivation for the time period, the answer is actually going to be T equals 2 pi root of L upon G. Okay, so that is what you will get while you do the derivation. Fine. So in that situation, I'll be able to get those constant also. But while you are doing like dimension analysis thing, you'll not be able to get that constant. Only thing that you'll be able to get is you'll be able to make a combination out of it, and then you'll be able to get that proportionality thing. Okay. The constant is something that we get while we know the experiment, and then while we know to deduce those equations. That is when I'll be able to get that constant. Fine. Right. So dimension analysis is used to verify that the dimensions of the left hand side and right hand side are same, so that the formula that we have found is correct. Okay, so for that thing we do the dimension analysis thing. From that we will be able to check whether the formula that we have derived is right or wrong. Okay, there are like two more extra things which you should know, right? The first one is same dimensional quantity can be added, subtracted, multiplied or divided. That is possible, right? Let's make it this way. 3 meter could be added with another one 2 meters. Okay, so 3 plus 2, when you join those two sticks, you'll get like 5 meters. That is possible. So same dimensional quantities can be added, subtracted, multiplied. For multiplied, it is like finding the area, right? Length into length, breadth. When you multiply those two things, you'll get the area. So same quantities can be added or multiplied. That is what they have given here. Added, subtracted, multiplied or divided. Okay. So only exception here is different dimensional quantities can be multiplied or divided. It cannot be added. For example, length of a rod is like 2 meters and then time is going to be 2 seconds. You can't add those two things, right? That is not possible. Length of the rod is 2 meters. That is a different thing. And then the time is going to be 2 seconds is something that I found from the clock. I'll not be able to add those two units, right? That is not possible. But it could be multiplied or divided. For example, velocity, I'll just consider it to be like meter per second, right? So these were different units, but I'll be able to divide, right? So same dimensional quantities can be added, multiplied, subtracted or divided, whereas different dimensional quantities can only be multiplied or divided. Okay, so this is the thing that you should know, right? So with this chapter gets completed. There is no more extra to it. The only thing that we are about to see is like screw gauge and the vernier caliper. Even though they are not part of NCERT syllabus, still you need to know, because more often in recent times you get questions from that screw gauge and then vernier caliper. Okay, so you should know how to get readings out of vernier caliper and then screw gauge, which we will do it in the next session. Fine. As if now everything in units and measurement has been completed. Fine. With this the video gets completed. Bye.